How are you, learner? My name is Dickens, and we are looking at effect of it on salts in today's lesson. We want to start by looking at, first of all, the effect of it on nitrates. So effect of heat on nitrates. Effect of heat on nitrates. So the products of heating nitrates generally depends on the position of the nitrate in the reactivity series. In that, those nitrates of the more reactive elements like sodium and potassium will produce different products. Those nitrates of those elements which are in the middle of the reactivity series will also give you different elements. And then lastly, those nitrates of those metals which are least reactive. So we are going to look at those three categories. Remember, you have said the products depends on the position of the element in the reactivity series. So we start with the sodium and potassium. So learner, we need to know this, that the nitrates of sodium and potassium, these two decompose on heating to give you two products. The products are the corresponding metal nitrite and oxygen gas. So we illustrate that using an equation. So sodium nitrate, solid, you heat. When you heat sodium nitrate, you'll get two products. Sodium nitrite, nitrite has an NO2, but a nitrate has an NO3. So sodium nitrite and oxygen gas. So don't forget, anytime you write an equation, you should balance. So we balance by putting 2 on sodium nitrate as well as 2 on sodium nitrite. It will balance because we are going to have 6 atoms of oxygen on the left. Also on the right, there will be 6 because of this 2 times 2, 4 plus 2, that will give you 6. The same applies to potassium nitrate. Potassium nitrate decomposes on heating to get the corresponding nitrite. Remember, we have said that will be potassium nitrite and oxygen gas. So we balance as usual. So we put 2 and then 2. So learner, we are saying that the nitrates of sodium and potassium decompose on heating to give you the corresponding nitrite and oxygen. We have said the products of effect of heat on nitrates largely depends on the position of the element in the reactivity series. So these two are at the top of the reactivity series. Therefore, their nitrates decompose to give you a nitrite and oxygen as the only products. What about those elements which are in the middle of the reactivity series? What products do they form when they are decomposed? So we are saying this, that the other metal nitrates decompose on heating to produce the corresponding metal oxide. Another product is oxygen gas, and the other product is nitrogen 4 oxide gas. Nitrogen 4 oxide gas. So this gas can be seen from the fact that it is colored. It's a colored gas, and the gas is red-brown in color. So we are saying this, that the other metal carbonates for those elements which are in the middle of the reactivity series, decompose on heating to give you the corresponding metal oxide, oxygen gas, and nitrogen 4 oxide gas. Let us illustrate that by using the following equations. So we start by zinc nitrate on heating from that general point, we expect to form the corresponding metal oxide, and the oxide that corresponds to zinc is zinc oxide. So we shall get zinc oxide. The other product is nitrogen 4 oxide gas plus oxygen. So actually we shall have a mixture of the two gases, but the distinguishing property will be the color. Oxygen, as we know from Form 1, it's a colorless gas, but this one is a gas that is red-brown in color. So when we'll be performing the experiment, you'll be able to observe some red-brown fumes. So those red-brown fumes will be evidence of nitrogen 4 oxide gas. Now remember, earlier on we said zinc oxide, the color, it has two colors. When it is hot, zinc oxide is yellow in color when it is hot. Then on cooling, it changes from yellow to white. So it's good we remind ourselves that point. The other metal nitrate is lead nitrate. Remember, these are some of the elements which are found in the middle of the reactivity series, which we have said decompose on heating to give you the corresponding metal oxide. So for the case of lead nitrate, our product, one of the products will be lead oxide, which is a solid. The other product will be nitrogen 4 oxide gas. Then the other product will be oxygen. So we mentioned earlier on the color. Lead oxide, when it is hot, it's red-brown in color when it is hot, and then on cooling, it is yellow in color. That is lead oxide. So it's also good we remember to balance our equations. We start by balancing. We have to make this one to be even. So the best way of balancing is we put 4 here, and then we shall have 4 atoms of nitrogen. So that calls for us to put a 2 here, so that we have the 2 times 2, we shall have 4 atoms of nitrogen, and then you put here a 2. So we shall have 2 lead atoms. Then oxygen atoms will be 3 times 2, that is 6, times 2, that is 12. So let us check how many atoms are there on the right hand side of oxygen. This is 2 plus 8 plus 2. That will give you 12. Also balance in the same manner. Our first equation, this will be 2, then this will be 2, this will be 4, like that. So that's how we balance those equations. Another example is copper nitrate. Remember, I have said these are elements which are found in the middle of the reactivity series. So the products of heating copper nitrate will be copper oxide, which we said earlier on is black in color, and then the other product will be nitrogen 4 oxide gas. Lastly, oxygen. Remember, we have said nitrogen 4 oxide is a colored gas, so it can be seen, putting in mind that the gas is red-brown in color. So we balance once again. Put 2 here, then 2, and then 4 on nitrogen 4 oxide. Another example can be calcium nitrate. Calcium calcium nitrate, when it is acted upon by heat, the products will be calcium oxide. Calcium oxide is white in color. Calcium oxide is white in color, plus a nitrogen 4 oxide gas, and then plus oxygen. Remember, you have seen nitrogen 4 oxide is red brown in color. So we balance 2, 2, and then 4, like that. So the equation will be balanced. Now, remember, these are elements which are in the middle of the reactivity series. Those which are least reactive, their nitrates behave differently in that instead of getting the corresponding metal oxide, they give us the corresponding metal, nitrogen 4 oxide, and oxygen. So we are going to illustrate that by using the least reactive metals, that is silver and gold, as follows. So as you know very well, silver is a less reactive metal. So its nitrate, when it is acted upon by heat, it decomposes to give you 3 products. So here we shall get the corresponding metal, and that is a silver metal, plus nitrogen 4 oxide, and then plus oxygen. So don't confuse. The other metal, nitrates, will give you the corresponding metal oxide, but those which are least reactive, the likes of silver and mercury, they will give you the corresponding metal, nitrogen 4 oxide, and oxygen. So the other one is gold. Gold, my dear student, has a valency of 2, and therefore that will be the correct formula. So when gold is heated, it will give you the corresponding metal, and that is gold, plus nitrogen 4 oxide gas, and then plus oxygen. So we have to balance the 2 equations. So let's balance. Of course, check. Silver is 1 on the left and also 1 on the right. Nitrogen, 1 atom on the left, 1 atom on the right. Oxygen atoms, 3 on the left and 4 on the right. So we have to balance by making the one on the right, on the left, to be even. So that's the best way. So if I put here 2, it will mean I will have 2 atoms of silver. Then I put here 2 so that the atoms of silver will balance. Next is I balance the atoms of nitrogen. I'm having 2 atoms of nitrogen on the left. I should also have 2 on the right. So I put here 2 like that. That will mean we also confirm oxygen atoms. On the left, this is 2 times 3. There are 6 atoms. Let's confirm how many are there on the right hand side. This is 2 times 2. That will give you 4 plus 2. That is 6. So the equation is balanced. Let us also confirm the atoms of the equation of heating silver nitrate. If mercury gold nitrate, if it is balanced, sorry. So we confirm the atoms of gold. So this is 1 atom on the left, 1 atom on the right. What about nitrate atoms? This is 2. So I'm having 2 nitrate atoms on the left, but 1 on the right. Lastly, atoms of oxygen. These are 3 times 2, 6. These are 2 plus 2, that is 4. So it's not balanced. So let us balance. So we shall put a 2 here on silver nitrate, a 2 on silver, and lastly a 2 on nitrogen 4 oxide, nitrogen 4 oxide gas. So will it balance? Let us also confirm. So it's a matter of you have to be sure if it is balanced. So when you do that, you realize that I will have how many atoms of nitrogen? This will be 2 times 2, 4. But remember, we have 2. So it's not balanced. So that means it calls for us to make a change here. So this will be 4 atoms of nitrogen. So once again, confirm oxygen. This is 3 times 2. That is 6 times 2. That will be 12 atoms of oxygen. Let us confirm how many oxygen atoms are there on the right hand side. This is 4 times 2. That is 8 plus 2. That is 10. They're supposed to be 12. So how do you make it 12? By putting here 2 like that. So the equation will be balanced. So those are the products of effect of heat on nitrates. I want us to look at finish by looking at the effect of heat on sulfates. Effect of heat on sulfates. Effect of heat on sulfates. Sulfates do not have so much. Just brief. But from the discussion we have just had here, we have seen that the products of heating nitrates depends on the position of the nitrate, the element forming the nitrate in the reactivity series, whereby we have said the ones which are more reactive will give you the corresponding nitrite and oxygen. Those which are in the middle will give you the corresponding metal oxide, nitrogen oxide, and oxygen. Those which are least reactive will give you the corresponding metal and nitrogen oxide and oxygen. So let us look at effect of heat on sulfates. Effect of heat on sulfates. So my dear candidate, I want us to know this, that the sulfates of sodium, potassium, calcium, and magnesium are very stable. They are stable. Of course, the main reason is because those elements are reactive, and for that reason, if they are stable, it means they are not affected by heat. They are not affected by heat. That means they don't decompose on heating. The only time when they decompose is if they are hydrated. So we're going to consider the example of sodium carbonate decahydrate. So sodium sulfate decahydrate. Sodium sulfate decahydrate. This one decomposes on heating to give you anhydrous sodium sulfate, and the 10 molecules of water of crystallization. So we have said it is only possible if it is hydrated. Otherwise, if it's not hydrated, then the salt will not decompose. The other hydrated sulfates also decompose to give you the corresponding metal oxide, sulfur, a gas by the name sulfur oxide, and water. So we are going to look at an example. All right, so we have said they'll give you the corresponding metal oxide, nitrogen, sulfur oxide, and water. So we are going to consider the hydrated sulfate of zinc. So hydrated zinc sulfate decomposes as follows. We get zinc oxide plus sulfur oxide and the 7 molecules of water of crystallization. The other one is copper sulfate pentahydrate. Penta means 5. It contains 5 molecules of water of crystallization. This one decomposes to give you copper oxide plus sulfur oxide, and then plus the 5 molecules of water of crystallization. So we finish by mentioning the effect of heat on hydrated iron 2 sulfate. Iron 2 sulfate behaves differently in that on heating, hydrated iron 2 sulfate decomposes to give you four products. The first product is iron 3 and 3 oxide. The other product, we have a mixture of 2 gases, sulfur 4 oxide gas. We also have sulfur 6 oxide, and lastly we shall get water. So those are the products of effect of heat on sulfates. So generally we have said sulfates only decompose when they are hydrated. So I want us to finish by looking at these questions. You'll try these questions, my dear student. Try these questions. First question: name the sulfates. Name the sulfates that do not decompose on heating. My dear student, name the sulfates that do not decompose on heating. Second question: comment on the effect of heat on sulfates. Comment on the effect of heat on sulfate. Give a general comment about the products of heating sulfates. Remember earlier on we were talking about nitrates. So our next question is write balanced equation for the effect of heat on our first one, sodium nitrate. Write balanced equation for the effect of heat on first one, sodium nitrate. The second one, lead nitrate, and lastly effect of heat on gold nitrate. So as you write the equation, don't forget to balance. So we have come to the end of our lesson for today. We have been talking about the effect of heat on nitrates and the effect of heat on sulfates. So under nitrates we have seen the products of effect of heat depends on the position of the metal nitrate in the reactivity series. For sulfates we have seen sulfates will decompose if they are hydrated. Otherwise, I thank you for being a good student. I'll see you in our next lesson. Thank you so much.